What I'm going to do today is go ahead and finish that homework example number 7. Now I'm going to finish the rest of section 8.4 because I only got like 2 examples to complete, and then we'll be done for sure with section 8.4 and with chapter 8, and then we'll start chapter 9. Now here we're talking about solutions to systems of linear equations, where in this case, here, pretty much a system has a unique solution if and only if the graphs of the equations intersect in a single point, or if we identify the slope and the y-intercept. If the slopes and the y-intercept are different, then that means the graphs intersect at a point. That means you're going to have one unique solution. No solution if the lines represent parallel lines. That means if the slopes are the same, but the y-intercepts are different. And also, a system can have infinitely many solutions if and only if the equations represent the same line. In other words, the slope and the y-intercept are exactly the same. Okay, so here's I did parts A and B. Now, here's part C. Let me stop sharing. Go here. One equation is y is equal to 2 minus x. The other equation is y is equal to x minus 2. And I want to pretty much solve, if possible, indicate whether the system has a unique solution, infinitely many solutions, or no solution. That y equal 2 minus x, I like to rewrite that as y is equal to negative x plus 2. I like to put the variable in front. I like to put that variable in front, and then go ahead and identify the slope and the y-intercept. Keep in mind the slope is the coefficient of the variable, which is in this case -1. The b, the y-intercept, of course, that's the number added to or subtracted from that variable, which is 2. Now for y equal x minus 2, that's this equation. It's already in slope-intercept form, y equal mx plus b, so we can go ahead and identify the slope there. The slope, again, the coefficient of x, that's 1. Your b, the y-intercept, that's going to be -2. And if you compare both of these, you can see that the slopes are different. So that tells me that this system of equations will have a unique solution. A unique solution. Any questions on part C? All right, part D, you got 7x minus 4y is equal to -1. And the other equation is -7/2 x plus 2y equal 1/2. And I want to determine whether this system has a unique solution, infinitely many solutions, or no solution. Okay, for each one of these, I'm going to get y by itself. So in this case here, I need to solve for y, meaning I need to move 7x over to the other side. And I'll do that by subtracting 7x on both sides. So this for y is equal to -7x minus 1. Then I'm putting the -7x in front and the -1 behind it. And now to get y by itself, I'm multiplying by -4, so I need to divide both sides. And in this case, I'm going to divide each and every term of this equation by -4. that y is equal to. Here, negative divided by negative will be a positive, so this will just be plain 7/4 x, and then minus divided by that negative will be plus 1/4. So here I have the equation y equals 7/4 x plus 1/4. So here the slope is 7/4, and the y-intercept is 1/4. Okay, next we got negative 7/2 x plus 2y is equal to 1/2. And here we need to write this in slope-intercept form as well. Well, in this case, I need to move the negative 7/2 over to where the 1/2 is. And I'm going to do that by adding 7/2 x to both sides. So that means I have the 2y by itself, and that's going to equal to, I'm going to put the 7/2 x in front, plus 1/2. And now I need to solve for y. I'm multiplying it by 2. Normally, you would divide both sides of this equation by 2. But what's the reciprocal of 2/1? How much? 1/2. So this is what I'm going to do. I'm going to multiply each and every term in this equation by 1/2. Okay. Since I got fractions over here on the opposite side, it'd be best to go ahead and multiply each and every term by the reciprocal of what's in front of that y. The reciprocal of 2 will be 1/2. That way, these 2's will divide out. You'll have the y by itself. That's equal to, now I can do 1/2 times 7/2. That's 7/4 x plus 1/2 times 1/2, 1/4. And from here, I can identify the slope and the y-intercept. Here, the slope is 7/4, and the y-intercept is 1/4. Notice that the slope and the y-intercept are both the same. And also, these equations are exactly the same as well. So that tells me these two are going to be the same line, and I will have infinitely many solutions. Infinitely many solutions. Questions on example number 7. All right, let me switch back here. All right, let's look at some application problems that are related to substitution and elimination. Like this one. The owner of a 4,000-gallon oil truck loads the truck with gasoline and kerosene. The profit on each gallon of gasoline is 15 cents, and on each gallon of kerosene is 12 cents. How many gallons of each fuel did the owner load if the profit was $540? So in this case, this is where we can write two equations, create a system of equations in two variables. This here. And I will show you how that's done. All right, so We're dealing with a truck that has gasoline and kerosene. So here's what I'm going to do. I'm going to let X be the number of gallons of gasoline. And then Y would be the number of gallons of kerosene. So if we have a 4,000 gallon oil truck and has 4,000 gallons of gasoline and kerosene, one equation would be this: X plus Y is equal to 4,000. That's one equation, because 4,000 gallons of both gasoline and kerosene are on that truck. So the number of gallons of gasoline plus the number of gallons of kerosene equals 4,000. That's one equation. Now here's the second equation. Gasoline, the profit on gasoline is 15 cents on each gallon and 12 cents for each gallon of kerosene. Okay. So X is the number of gallons of gasoline, and he's profiting 15 cents per gallon. 15 cents, and I'm gonna write this as a decimal, 0.15 times X. And then plus, he's profiting 12 cents on each gallon of kerosene. So that's gonna be 0.12 times, and we're letting Y be the number of gallons in kerosene, And that will total a profit of $540. So here's your second equation right here. So this is our system of equations that we're going to use here. We're going to find the number of gallons for gasoline and the number of gallons for kerosene. Okay, what I would use is the substitution method here. I would take that first equation, which is X plus Y is equal to 4,000. And I would solve that equation for X. Or you could solve it for Y, it doesn't matter which one you solve it for, okay? Because both of them have the coefficient of 1. Let me go ahead and solve for Y. And I'm going to do that by subtracting X on both sides. Means Y is equal to 4,000 minus X. Y equals 4,000 minus X. Then I'm going to use that Y equal 4,000 minus X and do the substitution method by substituting this Y here in the second equation with this expression 4,000 minus X. So here I'm going to have 0.15X plus 0.12 times, and I'm substituting the Y with 4,000 minus X. And that's equal to 540. So now, let's use the distributive property by simplifying this out. 0.15X plus, and then 0.12 times 4,000 gives us 480. Then minus 0.12 times X will be 0.12X. That's equal to 540. Combine like terms, 0.15X minus 0.12X, 3X plus 480, and that's equal to 540. And then to get the 0.03X by itself, we need to subtract 480 on both sides. 0.03 x, that's equal to 60. And then to solve for x, I'm multiplying by 0.03, so I need to divide both sides by 0.03. So that means that x will be equal to 2,000. And here x is equal to the number of gallons in gasoline. So that means there's 2,000 gallons of gasoline on that truck. And now we need to find out what y is. Well, we got y equal 4,000 minus x. So in this case here, since x is 2,000, I can substitute the x with 2,000, do the back substitution. So y will be 4,000 minus 2,000, which is 2,000. So to answer that question, there are 2,000 gallons of gasoline and 2,000 gallons of kerosene on the truck. Okay. Questions on example number 8. Okay. And finally, number 9. Using either substitution or elimination here. Kevin and Randy have a jar containing 91 coins, all of which are either quarters or nickels. The total value of the coins in the jar is $14.15. How many of each type of coin do they have? Okay. So in this case here, we're dealing with quarters and nickels here in that problem. So I'm going to let x be the number of quarters and then I'm going to let y be the number of nickels. Well, the jar contains 91 coins of nothing but quarters and nickels. So that means one equation would be this: x, which is the number of quarters, plus y, the number of nickels, is equal to 91. That will be one equation. Now for the second equation, we're looking at the total value of the coins in the jar being $14.15. Well, the quarters, the value of a quarter is 0.25 or 25 cents. And then there's X number of quarters, so that'd be 0.25 times X. And the nickel has a value of 0.05. And there are Y nickels, so it'll be 0.05 times Y. And that's equal to $14.15. And so here's my system of equations that I will solve for X and for Y. Okay. Now again, I'm going to go ahead and get Y by itself with this equation here. So I'm going to subtract X on both sides. So Y is equal to 91 minus X. And then we just do the substitution by replacing the Y in this second equation with 91 minus X. So this will be 0.25X plus 0.05 times Y, which will be 91 minus X. That's equal to, I'll leave off the dollar sign, 14.15. And then we just go ahead and simplify this equation. By solving for x, this will be 0.25x plus 0.05 times 91. That'd be 4.55 minus 0.05 times x, that would be 0.05x. That's equal to 14.15. And now we combine like terms, 0.25x minus 0.05x, that would be 0.20x plus 4.55. That's equal to 14.55. And then to get the 0.20x by itself, we subtract 4.55 on both sides to get 0.20x to be equal to 9.6. And then we divide both sides by 0.20. So x is equal to, that'd be 48. And here 48 represents the number of quarters. So in this case here, there are 48 quarters. And now we need to find out how many nickels. Well, y is the number of nickels and y is represented by 91 minus x. So we subtract 48 from 91. Let's replace the x with the 48, that's the back substitution. So 91 minus 48 would be 43. Okay. So to answer that question, there are 48 quarters and 43 nickels in the jar. Right. 43 quarters and 43 nickels in that jar. Questions on example 9. Or are there any questions about section 8.4? Okay, so that finally wraps up section 8.4. And